In this video, let's see how to model viscoplastic behavior of the material. Okay, so this is the mechanical analogy. So where there's a spring, and then series to that there is one friction damper, and there's another viscous damper. Okay, excuse me. Okay, so now if you see the total strain, which is from this point to this point, which has been additively decomposed into epsilon E and epsilon Vp. So let me write the total strain as epsilon, which is equal to epsilon E plus epsilon Vp. Okay, so now sigma is equal to Young's modulus, which is corresponding to the spring, into epsilon E, but I know I can use this relation. By exploiting this relation, I can rewrite the relation between sigma and epsilon as the following, which is equal to epsilon minus epsilon Vp. Okay, fine. Now say epsilon is known. Okay, so for the given problem, epsilon will be known, and so known quantities. So all the material parameters are known. In addition to that, the state variable epsilon for the current state, okay, or n plus 1th state will be known. Okay, and epsilon Vp for the previous state, previous load step, that is known. Okay, and yeah, all the other things are known at the nth step, but only n plus 1th step the epsilon is known. Okay, now what do we need to calculate? We need to calculate epsilon n plus 1 of Vp, and mainly sigma n plus 1. Okay, so this is what we need to calculate. Okay, how to do that? So for that, we need to construct some equations, evolution equation for this epsilon Vp, the viscoplastic strain. Okay, so let's see how to do that. Once again, we'll go back to this picture, and from this picture what we can say is, so this, between this point and this point, the strain will happen, or between this point to this point. Okay, so the epsilon Vp will change. Okay, will change only if this frictional damp is allow this thing to change. Okay, so for a given sigma, okay, so the maximum friction force, or which is an yield stress of this one. Okay, and since we have to consider for both the directions, so I will put modulus. Let's call this quantity as F. Okay, and this F has to be greater than 0. Okay, for epsilon dot Vp is not equal to 0. If epsilon Vp has to change, then this is the condition. And if F, or let me write like this, if F is less than 0, then epsilon dot Vp is equal to 0. Okay, because the force is not enough to overcome just this barrier. Okay, just this barrier, then it's not possible to move this. Okay, so that for that reason these are the conditions. Okay, now so epsilon Vp is going to change only if this condition satisfies. Okay, let me erase that. Okay, so if that condition satisfies, then what is epsilon Vp? Epsilon dot Vp is equal to the force acting on this damper. Okay, the force acting on this damper divided by the damping coefficient. Okay, let's call the damping coefficient as eta. So 1 by eta into the force. And what is that force? The force is the total force, which is sigma, minus whatever the force that has been beared by this particular element, okay, the frictional damper, and which is this F. Okay, therefore so the answer is F. Okay, but in order to satisfy these two conditions, what we do in general is we put Macaulay bracket. Okay, we put Macaulay bracket. So this Macaulay bracket means if F is positive, then the Macaulay bracket will give F itself, and if F is negative, then the Macaulay bracket will give 0. Okay, so delta F is equal to F if F is greater than 0 and equal to 0 otherwise. So that's the definition of Macaulay bracket. Okay, but one more thing, and this is the magnitude, and what about the direction? Okay, so the direction is it will evolve in, so this is just a magnitude, and in addition to that we have to give the direction. The direction is along the stress. Okay, because that you can see, so if the if we are pulling, then the epsilon dot Vp is going to increase, and if we are compressing, it's going to decrease, right? So therefore we can easily say that epsilon dot Vp is equal to Macaulay bracket of F by eta sine of sigma. Okay, so now what we are going to do is, so let me get rid of this, for a while I will get rid of this Macaulay bracket, and let's say I am just considering this case, okay, which means the F is positive, and only for that I am considering. Okay, if that's the case, then epsilon dot Vp is equal to 1 by eta into modulus of sigma minus sigma y into sine of sigma. Okay, now in order to calculate epsilon dot Vp, I need to know sigma, but I do not know sigma, right? So all I know is this one, okay, at the n plus 1th time step. So what am I going to do? Let me use this equation. Okay, so if I use that equation, then what do I get? Epsilon dot Vp is equal to 1 by eta modulus of epsilon minus, there will be Young's modulus into epsilon minus epsilon Vp minus sigma y sine sigma. Okay, so now what we are going to do is I am going to introduce a parameter lambda, which is the magnitude of epsilon dot Vp. Okay. So if I introduce like that, then what I can say, and I know the direction, which is sine sigma. So lambda is equal to, from this equation I can say lambda is equal to 1 by eta E into modulus of epsilon, or otherwise I'll do something else. What am I going to do is, say I'm going to multiply, let me remove this. Say I'm going to multiply this sine sigma inside. If I do that, then epsilon dot Vp is equal to 1 by eta okay, let me go back to one more step. So let me start from this step. Okay, from here, if I multiply the sine sigma inside, what do I get? Epsilon dot Vp is equal to 1 by eta into modulus of sigma into sine sigma is just sigma, minus sigma y into sine sigma, right? Okay, now what I am going to do is epsilon dot Vp is equal to 1 by eta, let me write from here, E into sigma, sorry, not sigma, epsilon minus epsilon Vp minus sigma y sine sigma. Okay, now in this one, let me do one thing, let me discretize it and let me write, so such that epsilon dot Vp is equal to epsilon Vp in the nth step plus delta epsilon Vp. Okay, yeah, so if I write it like that, then divided into delta t, okay, is equal to this. So in that case, what I can do is epsilon Vp in the nth plus, sorry, am I right? Yeah, okay, I have made a mistake. Epsilon dot Vp is equal to okay, let me make it clear. So epsilon Vp n plus 1th time step is equal to epsilon Vp nth time step plus delta epsilon Vp. Okay, and we know what is epsilon Vp dot, which is nothing but P, so many mistakes, Vp dot is equal to delta epsilon Vp by delta t. Okay, so the discretized one. So in that case, here the place of epsilon dot Vp I can write delta epsilon Vp by delta t, which is equal to 1 by eta E into epsilon, and everything I will put it in the discrete form, so it will be n plus 1 minus epsilon Vp n plus 1. Okay, it should be n plus 1, but in the place of n plus 1 I am going to put this one. Okay, so n minus del epsilon Vp, okay, minus sigma y into sine of sigma. Okay, so far it's fine. The one thing in this equation, as a matter of fact, there are two things I do not know. One is delta epsilon Vp, okay. The other thing is sigma, and also sigma should be sigma n plus 1. Okay, the other thing is sigma n plus 1. So, but we have only one equation, but somehow I can identify sigma n plus 1 using the following. So, I am going to introduce sigma trial of n plus 1, okay, which is equal to E into epsilon n plus 1 minus epsilon Vp of n, okay. So that's trial, and we can calculate the trial sigma easily, okay. As a matter of fact, sine of sigma trial is equal to sine of sigma, okay. And because of that fact, what I can say is delta epsilon Vp by delta t is equal to 1 by eta E epsilon n plus 1 minus epsilon n Vp. Okay, so this is what I'm writing, but what am I going to do is I'm going to put the bracket, and then I'll rewrite minus E into delta epsilon Vp, okay. I'm going to write like this, and minus sigma y into sine of sigma trial, okay, n plus 1. And what is this term? This term is nothing but sigma n plus 1 trial, okay. So delta epsilon Vp by delta t is equal to 1 by eta sigma trial minus E into delta epsilon Vp minus sigma y sine of sigma n plus 1 trial. Okay, so let's rewrite it further. So delta epsilon Vp, let me multiply this whole thing with delta t, so that I will get delta t by eta sigma trial minus E delta epsilon Vp minus sigma y sine sigma n plus 1 trial. Okay, as a matter of fact, delta t by eta sigma trial minus, so I'm just writing these two terms, sigma trial minus sigma y sine of sigma n plus 1 trial minus delta t by eta E delta epsilon Vp. Okay, so I made a mistake. So sigma trial, okay, everywhere I have to change. So sigma trial should be like this. Okay, so please modify it over here as well as over here. Okay, now let me take this over this side, so that what I will get, delta epsilon Vp into 1 plus delta t by eta E is equal to delta t by eta into, so this is nothing but say initially we have defined f, right? So f is basically a function of sigma, right? So now if that's the case, then this is nothing but f of sigma trial into sine of sigma trial. Okay, and then delta epsilon Vp is equal to finally eta, let me write this one, 1 plus delta t by eta E and f of sigma n plus 1 trial sine of sigma n plus 1 trial. Okay, as a matter of fact, this will have some, this is valid only if f is positive. Okay, otherwise delta epsilon Vp is 0. So that condition we can take care by putting the Macaulay bracket over here. Okay, so now using this formula, once I calculate delta epsilon Vp, then sigma is nothing but sigma n plus 1, or before that let me calculate what is epsilon Vp n plus 1, which is epsilon Vp n plus delta epsilon Vp, and this leads to sigma n plus 1, which is equal to E into epsilon n plus 1 minus epsilon n plus 1 Vp. Right, so some of the important relations, this one, and then this one, yeah, mostly that one. Okay, and you should know how to calculate sigma trial, and that sigma trial is this one. Okay, so that's how you need to construct the equation and make a model for viscoplastic material. Okay, thank you.